In this video, we will try to prove the trigonometric identities shown below. We are going to solve these three identities using the fundamental Pythagorean trigonometric identities, which are sin square theta plus cos square theta is equal to 1 plus tan square theta is equal to secant square theta, and 1 plus cot square theta is cosecant square theta. So let's try to solve each one of them. So let's solve the first one. So here we have to prove that secant A times 1 minus sin A times secant A plus tan A, this is equal to 1. So let's convert secant A to 1 by cos A, and let's retain this sin A. So basically what we are trying to do is we are trying to change secant A and tan A to its original form, the basic definitions of sin, cos and tan. So secant A again can be written as cos A, and tan A can be written as sin A by cos A. So now if you notice, cos A is the common denominator, correct? So this can be written as 1 minus sin A by cos A times 1 plus sin A divided by cos A. Now this is of the form A minus B, A plus B. So it can be further changed to 1 minus sin square A divided by cos square A. Now we know that cos square A plus sin square A is equal to 1. So 1 minus sin square A would again be equal to cos square A. So basically we are cancelling out the numerator and denominator, and we get the value of 1. So now you might have a question, how do we even know how to approach this problem? So trigonometry is only about how many problems you have solved. It all comes with practice. So more problems you practice, easier it is for you to assess a problem and then get to a solution. So there is no luck in trigonometry. Please practice and you will definitely be successful. If you like the video, please share it with your friends, subscribe to the channel and like the video. Thank you so much. Now let's address the second problem. Here we have to prove that cot A minus cos A divided by cot A plus cos A is equal to cosecant A minus 1 divided by cosecant A plus 1. So basically we see that we have two trigonometric functions, cot and cos, and it further changes to cosecant A. Cosecant A is nothing but 1 by sin A. So if we have to derive sin from this value, we have to go to the original definition of cot, which is cos A by sin A minus cos A divided by again cos A by sin A plus cos A. Now what can be done here? We see that in the numerator, cos A is common in the numerator. So this can be further written as cos A 1 by sin A minus 1 divided by cos A is common again in the denominator. So this will be 1 by sin A plus 1. So cos A gets cancelled. So 1 by sin A is nothing but cosecant A minus 1, and cosecant A plus 1 is the denominator. So that is what we wanted to prove. So it's as simple as that. So please keep the definitions of tan, cot and all the inverse functions in mind, and you can solve any problem in trigonometric identities. Let's solve the third problem. Here we have to prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1 is equal to 1 by secant theta minus tan theta. So here we see sin cos changing to secant and tan. So sin can be changed to tan if we divide it by cos. So what we can do is let's divide the numerator and denominator entirely by cos theta. So we can rewrite it as sin theta by cos theta minus cos theta by cos theta plus 1 by cos theta. So this is your numerator now, and denominator again will be sin theta by cos theta plus cos theta by cos theta minus 1 by cos theta. So what will this be? Sin theta by cos theta is tan theta minus 1 plus secant theta. Correct? Now the denominator will be tan theta plus 1 minus secant theta. Now we have reached a dead end and we cannot simplify this further. So in these scenarios, we have to think, if we multiply and divide this equation that we have arrived by something like a minus b, a plus b, which is equal to a square minus b square, or is it possible if we apply a square plus b square is equal to a square plus 2ab plus b square, or a minus b the whole square. So we have to see if what happens if we rearrange this equation so that we get tan square, secant square, or any other trigonometric ratio squared, because all our identities are in the square format. For example, cos square theta plus sin square theta is equal to 1, or 1 plus tan square theta is equal to secant square theta. So now what we can do is, if we apply that approach, let us multiply and divide this equation by tan theta minus secant theta. So what we can do is tan theta minus secant theta divided by tan theta minus secant theta. So this is nothing but 1. So we are just rearranging this equation times whatever we arrived at, tan theta minus 1 plus secant theta divided by tan theta plus 1 minus secant theta. So we did not change the value of the equation at all, because this cancels out, these two things that we added cancels out to be 1. Now if you notice here, if you rearrange this, so this is a minus b and this is a plus b, if we consider that same way, what we can do is, let's multiply this. So this will be tan square theta minus secant square theta, then we have minus 1 minus 1 times the whole equation again, tan theta minus secant theta divided by, the denominator remains the same, we cannot do anything with that. So this will be tan theta minus secant theta times tan theta plus 1 minus secant theta. Now we know that 1 plus tan square theta is equal to secant square theta, correct? So if we rearrange this, tan square theta minus secant square theta would be equal to minus 1. So minus 1 times minus 1 minus tan theta minus secant theta divided by tan theta minus secant theta times tan theta plus 1 minus secant theta. So let's rearrange it now and see what we arrive at. So this would be minus 1 minus tan theta plus secant theta divided by tan theta minus secant theta times tan theta plus 1 minus secant theta. So let me fix this for you. So this is minus tan. Okay. Now if you observe here, the numerator and this part of denominator is nothing but a negative version of each other. So if I take minus 1 as common, so this would be 1 plus tan theta minus secant theta divided by, divided by tan theta minus secant theta times tan theta plus 1 minus secant theta, correct? So we can cancel these two, and then this minus 1 can be again rearranged if we take a negative value, if we take a minus 1 as common between this. So this would be 1 by secant theta minus tan theta. So I hope you understood what we did with the negative signs here. Please pause the video, and if you want to retry it, please solve it yourself and you will arrive at the solution. Thank you so much for watching. Please subscribe to the channel and like the video. I'll see you in the next videos. Thank you.